what is the meaning of probability of 0 and probability of 1. As I mentioned, it's not always impossible. Probability of 0 doesn't mean impossible, and probability of 1 doesn't mean certain. Let me give an example so that you understand. So for example, let me continue with the same example that I was doing. So on the number line, I have 1 and 2. As we know from the earlier discussion, that there can be infinitely many points between 1 and 2. Okay, so now I ask you that what is the probability of getting 1.5? If I take my pen and put it on this number line, what is the probability of getting exactly 1.5? What would be the answer for this? That would be, probability of this will be almost equal to 0, because there are infinitely many points here. There can be anything, like for example, there can be 1.5, 1.51, 1.4911, 1.4999999999, 1.51111111, like that. There is no limit to this. So there can be infinitely many such points between 1 and 2, and there will be more numbers like this here. So what is the probability that out of these infinite points, that I put my pen exactly on 1.5? So this will be almost equivalent to 0, because there are so many points. So that is why we say that it's okay. This is not impossible, but can you say that? Can we say that it's impossible to put my pen on this point? No, right? So that's why we say that there are infinitely many points. So probability of 0 means highly unlikely, not impossible. Because there is some chance that, because this 1.5 is there, so there is some chance that I can put it here. But for all practical purposes, we say that probability of putting my point on 1.5 is 0. I hope that is clear. So that is highly unlikely. Similarly, if I put the question in the reverse order, okay, so my question is, what is the probability of not putting my point on 1.5 exactly? What is the probability of not putting my point? I will choose, if I put my pen here, it should not fall on 1.5, anything apart from this. Okay, so can you say for sure? So what will be the probability? So since there are infinitely many points here, so can we say that not choosing 1.5, what will be the probability of this? Exactly, what will be the probability? We can say that this will probability of not choosing 1.5 will be equal to 1 for all practical purposes, because there is almost, okay, we can say that it's because choosing 1.5 is so low that we can say that of not choosing 1.5 is 1. But can we say that for sure? Again, the other way around, that whatever I do, I'll not be able to use 1.5. We cannot say that surely, right? So that's why probability of 1 doesn't mean certain or sure. We say that this is almost sure or certain. It's not certain. In this continuous case. So this is the more accepted definition of probability of 0 or 1. Okay. But in practical terms, we discuss with mostly finite or discrete numbers. So from there, the definition that whatever we understand, that p equal to 0 is impossible and p is equal to 1 is certain or sure. So this definition, what we know, comes from there. And I can give you a counter example also where this definition holds, and you guys will also know. Let me give you a quick example so that you understand. For example, when will this definition of probability p equal to 0 and p equal to 1 hold? Say for example, if I roll a die, I'll ask what is the probability of getting a 7. We can say that this is a 0, right? So that's why, and here in this case we can say that it's impossible to get a 7. Here this definition holds, that getting a 7 is impossible because our set only contains 1, 2, 3, 4, 5 or 6. There, this in this case this definition will hold. Okay, and similarly, if I roll a die and if I say that what is the probability of getting any of these numbers, any of 1 or 2 or 3 or 4 or 5 or 6, in this case we can say that this is sure that I will get, and this is impossible. So in this case this definition holds, but for our practical purposes we use this, that probability of 1 is almost sure and probability of 0 is, where did it go, where did I, this is highly unlikely. I hope that is clear. Okay,